Hello, Professor. Today we're going to showcase our project. It is called EEDA, which stands for Early Earthquake Detection Alarm. This is me, Mohammed Miladi, and Abdulrahman Al-Arfawi. In light of recent events in Morocco, in Marrakech to be specific, we've seen how the massive earthquake destroyed the infrastructure of the city and ruined many lives and many buildings. So, in light of these events, me and Abdurrahman thought of a solution for this problem. We wanted to make a device which notifies the people beforehand, before the earthquake actually happens. In order to put everything into context, we're going to make an example, demonstrate an example. So this is an example of cats, animals. They're relaxed, they're not doing anything, but suddenly they sense something. So everything is normal according in our point of view, human point of view. But for the cats, they sensed the earthquake before it actually happened. So as you can see here in the graph before us, we have two main kind of waves, P waves and S waves. P waves happen before the S waves. The S waves are the actual earthquake, so they are much stronger than the P waves. And there is a delay on average 10 seconds between these two waves. So what happened in the video before? So the cats, we know that the cats are more sensitive than humans are. That is why they sensed the P waves 10 seconds before the S waves. So if we put, for example, if we put a human and alongside a cat, the cat would sense the P waves while the human would not. So our solution is EEDA. This device, it is an easy-to-use alarm for individuals to put in their homes in case of earthquake. It will ring a couple of seconds before the real impact happens. So as we've seen before, 10 seconds in average in impact, allowing the occupants to seek shelter. So this alarm is 114 decibels in intensity.
So this is our prototype, our box. I'm first going to turn it on to detect the vibrations. So now the sensor, when it will detect the vibrations, it will, using the Arduino, turn on our alarm. So let's try. Now I turned it off.
So our box contains these components. It works with an Arduino, and along with this Arduino we have a sensor called the MPU sensor. It's an accelerometer gyroscopic sensor that actually senses the very small vibrations of Earth. Using this sensor, we will be able to activate a relay that will activate itself our siren, our alarm, because our alarm needs external power. It needs to be plugged to the power source in the wall. We have 220 volts. Of course, we have an on and off switch to turn our alarm on and off, and an LED that has the state of our device. On the left side, we have our schematics with the detailed electric circuit of all our components wired together. Let's have a closer look to our MPU 6050 accelerometer. So this is the key component of our device. It senses the vibrations of Earth using a flexible capacitor inside. It has 3D sensor. It has 3D sensing, the X, Y, and Z axis. We find this sensor everywhere in our daily lives. We have it, for example, in our smartphones to detect the orientation of our smartphone. For example, when we want to play a video, or for example, when we want to play a video game. We find them in drones, for example, in satellites, and many more. And this is an example of an earthquake that was sensed using this exact sensor. We can clearly see here, as my friend mentioned before, the P waves and the S waves. We can also run a MATLAB analysis to see more details about these waves, as you can see here on the bottom.
So before us is the code for, of course we coded this using C++. This is basically a simulation of a real earthquake. So as we can see here, we have x, y, z coordinates, and we have a max value for each coordinate. So the vibration when the MPU sensor senses the vibrations, we have a threshold, which is the max value. When the max value is exceeded, then the alarm will be triggered.
On the right side, however, we have the example when there is no earthquake. Here in the graph, we can see that all our waves are regular and they are oscillating in a regular way. Here we can see that there is clearly no earthquake. And on the left side, we can see that the waves are not regular. That's why we have our earthquake triggered. Here we can see the configuration of our sensor using the different frequencies and the XYZ gyroscope references that we code. For our device, we use the MS190 siren. It is widely used in many places, especially in the fire fire safety industry. Here on the left side we have a simulation of the propagation of sound in a typical house, where you can see that our alarm, our device is here, and how the sound is propagated throughout the house. So it is very important for the user to place the device correctly in a strategic place so the sound can be heard everywhere in the house and even outside the house. Here on the right hand we have the specifications of the siren. We have a frequency of 60 Hz and, as mentioned before, 114 decibels for 220 volts power. Before building our prototype, of course, we designed our device in SolidWorks, as you can see on the right hand. We will dive more into it later. And to build the case of our device using wood, we used the laser cutter, we used the RLD file using SolidWorks, and we cut it in Timdaqin with the Sibrahim.
So as you can see, Professor, this is our 3D model in SolidWorks. So this is the box. It is 8 by 13. So the height here is 15, the width is 8, and the length is 13. So I'm going to hide the some components in order to see the inner components. So here I'm going to choose wireframe. As you can see here, inside we have the Arduino Uno device circuit. This is the relay which Abdurrahman talked about, and this is the MPU sensor which senses the earthquake and sends the signal into the relay in order to trigger the alarm, which is here. So this is the siren, which is 114 decibels, and this is the power plug, the power outlet, which takes approximately 200 volts. So as we've seen, the main purpose of our device, EEDA device, is to save as many lives as possible. So that is why we thought of two main solutions in order to enhance our product. So we thought of getting into contact with a standardization company. We found ISO 9001. This is a quality standardization which enhances the reliability of our product. So we also thought of getting into contact with the government in order to connect our devices to the internet in order to analyze data and perhaps avoid potential disasters.
That was our project for today. Thank you very much for listening. See you soon in class.